What's up, everybody? Welcome back. Today, we're looking at trying to use Twitch accounts to log into my website. So the idea is we've been working on this project, this long-term project of this, like what you're seeing here, right? So the idea is that we're gonna have like these like balls rolling around this physics simulation, and they're going to go through different chambers. Right now, these chambers aren't like hooked up together, so we have like two individual ones. But eventually, the idea is that the balls will like move through these chambers to form some complex web of things, right? And the interesting part of this project is that both of these chambers are like fairly defined by WebAssembly modules. So like these platforms are being rendered by a WebAssembly module on the client, as well as the physics simulation of like how the balls respond to hitting those platforms. These are also defined by a WebAssembly module. And the idea here is that since WebAssembly is like fairly sandboxed, I want like users to be able to like log in and design a chamber and upload it, right? And they like designing a chamber is just writing a module that like conforms to this API. And I want them to be able to like upload and maybe like manage their modules. At the very least, like we can maybe like give credit to like who uploaded what module, etc. And I want these like logins to be tied to a Twitch account, right? So at the very least, that way, if somebody in my chat does something like really, really, really rude, right? We can like punish them on Twitch as well, which is like a little bit of a benefit. But really, I think probably like the crediting of these things is probably the most compelling reason. And so to do that, we need to like somehow ask Twitch to tell us who is interacting with us, right? And so googling around, I see this like this concept of OpenID Connect, I think is what they call it. Wikipedia maybe. And I think that this is how we are supposed to allow users or allow like a third party service to tell us who is interacting with us. There's also this idea of OAuth, which supposedly is different. We'll pretend that I understand why, but I don't really. And what I here, this little diagram on Wikipedia kind of like says the difference. So OAuth, you say like, hey, website, Twitch. Could you you ask like a user of your website, hey, user, could you like tell Twitch to give us a key to access on your behalf? Right, so they'll say like, you give a link to a user, they click on the link, and then redirects them to Twitch, and that link says in it like, hey, go to like spheraphoria.com and give him a code. Assuming that the user clicks yes. And they give us a code that lets us like behave on the user's behalf. And apparently that's slightly different than us asking the server to say, hey, could you tell us who this is? Right, those are subtly different, right? It's like in this diagram they're saying like, so they give you a key and they get the key represents that like I have access to this guy's house, but that doesn't mean that like I am that guy, right? And so like there is like some slight differences there. So I think OpenID Connect is like this thing built on top of OAuth, if I understand correctly, but I really don't understand that much at all. So the approximate plan is there is not very much of an approximate plan. It's like let's try to like work through this like OpenID Connect flow, see if we like understand it. Once we get through it like once, like doing like whatever manual tricks we have to do, then we can start like implementing like a real thing that validates the things it has to do and stuff. But as of right now, I just feel like it's like let's just start running it, and we'll build up a mental model of how these things are supposed to behave as we go. I guess I will start off by drawing out my current mental model so that like we can start on the same page. I'm sure that like whatever page I'm on is not the right page. Approximate plan 1, make it work. Optional, yeah, pretty much. So my current understanding is, which again could be wrong, right? Well, let's just get us on the same page so that as we learn, we're learning the same things. So I have like my website server. I guess I should call it server because there's more than one server at play. So I think there's like, spheraphoria.dev, right? And this is where my website's gonna run. And this is like, we'll kind of say that like this is like a servers, and here is like client, right? So like the client is going to be served some website from spheraphoria.dev, and so that's kind of like here as well, right? And this is gonna have like a button on it that says like log in with Twitch. And that's going to redirect them to some like Twitch Twitch login with like some parameters, right? So I'm gonna say like go to this website on Twitch with something in my query parameters that say like spheraphoria.dev. Then like the user is going to be presented with some dialogue that says like, oh, why the fuck did my maze crash? That's annoying. But we'll fix that later. So the user is going to be presented with some dialogue that says like, would you like to give this guy access to your account? And then that will send something over to the Twitch servers. Twitch. And Twitch will be like, oh, sure, yeah, we'll give that to you. And then they will send something directly to me, I think. That's my understanding so far. That says like auth token. And then from then on, I can do like whatever I want to go back and forth this way. And then what should happen is that this will respond here with a redirect that sends me back over here. That's my understanding. I don't know how like correct that is, but that's my understanding. And so I assume that like once we get this auth token, we should then do something else. Like we will ask the server, hey, like, is this really the guy he said he is? And we can like do some extra confirmation there. That's my understanding. But who fucking knows? Okay, fixing the maze. Give him a sec. He's got to think. There we go. Let's kind of slap this guy. There you go. That's about right. Okay. So I have registered an application on Twitch. I call it Ball Machine, and I think that I tell him like, hey, when you want to talk to my service, go here. And right now I've just punched in localhost, and so we'll have to start up a web server like locally, I think, to deal with this. But we might be able to dodge that for the first attempt. I need to like generate a client secret, so I'm gonna like here. We'll make a. Maybe we will make some file somewhere, I guess here, and we'll call this like client creds JSON or something, and we'll say ID is this thing. You guys are allowed to see this. I don't see any reason that would be a problem. But what you shouldn't see is the secret. So how do I do this? Let me generate a new secret, copy it, go off screen, and write secret. And I think there's like pretty narrow consequence to you guys actually seeing this, to be honest. But we'll try our best to not let you see it anyways. And hopefully that's good enough. And so then what we should be able to do is when we're experimenting with this thing, maybe we can run these requests without you guys seeing what you want to see. But again, I think that I'll just like regenerate everything at the end of this, so it's not really the end of the world. Not the end of the world. Okay, so I think that the Twitch authenticating users, I think that somewhere they talk about like different authentication flows. And they talk about like this took me a long time when I was reading this to like even understand what the hell they're talking about, because they talk about like use one if you have like server to server and one if you're client to server, and I'm like, well, my service is a client of that server. But I think what they basically mean is like if I'm expecting to do things on behalf of the user on my website, which I am, I think it's the server to server flow. And I think we just run this and see what fucking happens. So they say, hey, first we're going to go to OAuth authorize, and we're going to give it a bunch of parameters. So we get the user to go here. So that's kind of like fits the mental model that we have so far, that like we redirect the user to Twitch through like some shenanigans. So I guess maybe let's not get ahead of ourselves. We shove a bunch of query parameters in here. So client ID is like, this is our identifier. Like, who are we? We registered as Ball Machine, so this is probably going to display something about Ball Machine. Claims is a string encoded JSON object that specifies the claims to include in the ID token. I don't know what that means, and it's not required. Is it in this example? No. So we'll skip it for now and we'll come back to it. Force verify, set to true if you want them to reauthorize, sure, so that's probably just for testing nonce. Although optional, you are strongly encouraged to pass a nonce string to help prevent CSRF attacks. The server returns the string to you in the ID tokens list of claims, blah, blah, blah. Sure, okay. I was looking at this before stream. I was reading about cross-site request forgery, and I like kind of get it, like, as a concept, right? The idea that, like, you know, your bank has a form on it, and like if you have like give money URL, you have some like endpoint that's like give money, right? And say like you're authenticated in some way, your browser's gonna have some cookie that allows you to go to like bank.com/give money. And so like you just go to some random website and they're like, hey, click this button. And you click the button and it like redirects you to bank.com/give money, but like with some guy as like as a recipient. That's a problem, right? And so the idea, if I understand it correctly, which I might not, is that the bank, every time that you load like this give money is like a JSON endpoint, right? And this is going to be shown on like, you know, give you know, transfer.html or something. I think the idea is that like every time you load transfer.html, they generate like a random string. So they go like 1 2 3 4, right? And when you call give money, you have to say like, and number is equal to 1 2 3 4. And the idea is that now, like, if you go to another site and they redirect you to bank.com/give money, they're not going to know that the number is 1 2 3 4 because the number changes every time, right? And so like you need to like this prevents just like random sites from getting you to like accidentally click on links and go somewhere. Now, in the context of like me asking a server, like me saying, hey, could you authenticate with my application and send the response code to my website? I don't understand what the threat model here is. Like what cross-site request forgery could possibly happen in this scenario. But maybe it'll become more clear as we run through the flow. So probably what we'll do for now is we will generate this thing, and then we'll come back to it and be like, why do we need this later? This is like where the server is going to send the response to. So when we say, hey, Twitch, could you let this user log in for us? He'll be like, okay, yeah, they're good. Who should I say that to? This is us. Response type must be set to code. Okay, simple. If it must be set to that, maybe you wouldn't have to include it, but maybe there's like other flows where this could be set to something else. So fine, whatever. Scope. So this is, I think that like this is like actions that I want access to, right? So you could log in and say like, I want to be able to send chat messages on this guy's behalf. I think that's what these scopes are, right? You can say like, oh, I want to be able to like create polls for this guy, and I want to be able to read his polls, and I want OpenID. So they're kind of saying we must include OpenID if we're trying to get an ID for this guy, sure. And then some more state related to CRSRF. And when I was reading this pre-stream, this is where I was like super fucking confused. I was like, surely me sending a user to this URL with this like thing copy pasted twice, surely this is not the right answer, right? I mean, I could be wrong, but this does not seem correct to me in any way, shape, or form. But I don't know what the fuck I'm talking about, so let's just do this, I guess. So did we lose our page that has our client ID? Because I just realized that I had the client ID and the client secret in the same file, so I can't actually extract the client ID from my file system very easily. But let's start by just going there and see what happens. So login. I guess we'll call it login text, and we will paste our client ID here, and then we will copy paste this, and just see what it does. So here we replace the client ID with ours. And then I guess we will kind of slap all this stuff together and fix the spaces. Our redirect URL was not 3,000, but it was 8,000. And I don't think that we want anything but OpenID for now. So how do we, let's delete everything until the word OpenID on this line. There we go. And let's just kind of see what happens if I paste this into my URL bar. Okay, Ball Machine wants access to your account. So this is me. Authorizing you will redirect me to this website. And this was created less than a day ago, not owned or operating by Twitch. And it doesn't really say what I'm going to do. If I were to go back in here and add back in those other scopes, does it at least tell me like, hey, this guy wants like access to do some malicious action? Ah, yeah, okay. So this now says like, hey, these are the things that they want that it will be allowed to do. But if all we say is OpenID, it just says you go there. Okay, that's fine. That's fine. Make sure that you trust Ball Machine. I don't trust Ball Machine. I don't trust me. Are you kidding me? That guy's an idiot. Okay, so where does this tell us to go? So this sends me back to my address with this code and this state. So this state matches the state that we passed in. They have no scopes, and so we presumably can use this code to do something. And then someone in my chat is going to like read that code, and they're going to like fuck us over by using it in some way before we get to it. And fuck that person. Don't do it, please. Please. Okay. So if they click authorize, we get something like this. And to get the tokens, okay, so we use the authorization code to get a token. So this token is, I think, how we actually authenticate with the server. We say, hey, this is like a one-time code, and we are going to send that somewhere. So what is the easiest way for me to like seriously replace your client secret off the screen? Yeah, I will. I'll probably nuke the whole app and reset it, to be honest. Too late, already used the hack Bava. Yeah, fuck. I mean, I think that like the limit of the damage that you can do with this thing at this point in time is like very, very low, right? All you can do is like ask people to log it to like authenticate with Ball Machine, and they just won't. I would think. I hope. But you know, if I kill the app after, then like they'll lose anything anyways. Okay. So here, I post with URL encoded parameters as the body of the post. Okay, so I need to like curl-x post-data, and presumably I can just kind of like do this. Let's just start here and see how fucking mad it gets. Redirect 8000. No URL specified. Right. So this goes to this place. Yep. And oh, oops. This is the data, and the location is this. I see. No URL specified? Am I high? What did I do wrong here? Man curl -x post, yeah, and then -d is not -d the way to like add data? Data, yeah. To URL encode the value of a form. Maybe I should use data URL encode. Okay. So -data URL encode, and I guess maybe we put this whole thing in quotes just in case. And then maybe this has to go at the beginning or something. Okay, there we go. Invalid client. So we should now be able to let's think about this. If I say JQ client JQ.id from client creds JSON. Okay. Okay. So this prints the ID. Can I get it without the quotes? JQ print field without quotes. I'm trying to think like what's the easiest way for me to like execute this request without like you guys seeing the parameters. And can I like get rid of the new line as well? JQ, no, new line. There we go. Okay. So this is a way for me to extract a thing. And I should be able to just kind of shove this in my command line somewhere. So curl client ID is, we'll start with just the ID. And then if this works, fuck. I guess what we could actually do here is we could just put them as environment variables and then just hope to God we don't leak them. Let's do that. Okay, one sec. Cat client creds, and I will say export client ID is equal to this thing, and export client secret is equal to this thing, and then we will clear and reset, and echo client ID. Okay, I think we're back. So we should be able to curl, and let's, instead of doing this JQ shenanigans, we'll just write client ID, and here we'll write client secret. And the code is whatever code we got back here. Fuck! Invalid client. Did I get my client ID right? Echo client ID. That looks the same. So we are doing something fucking stupid. Maybe I have to write the and, like, let's look at their example again. Here. Oh, maybe, do I have to, like, maybe write somewhere that my parameters are XWW form encoded? I wonder. Okay, here's what I'm gonna do. I'm gonna type this with -v, and then do this off screen real quick, just to see what's actually being sent. Oh, it actually doesn't even show it. Maybe I have to do -vv. 2 V's for more verbosity. It does say that it is doing form URL encoded, and that it sent off the things correctly. So I don't see why it'd be a problem. Am I going to the right place? They're saying that I'm supposed to go. So I'm supposed to run this thing, authorize, which I did, and I got this response. And then, oh, I wonder if I like didn't save my client secret or something. If I hit new secret here, it generates me a secret, but then there's like no save button. So maybe I have to save after I generate the secret. I click the I'm not a robot button. The save button comes up good. Hold on. hold on. We can get there. I'm gonna edit my credentials here, paste this, and then export client secret is this, and then edit my history because that was a little scary. So bash history and look for client secret. Just delete these lines. I know you guys aren't seeing shit. That's intentional. And then clear and reset. Let's try this again. We try again. Oh, fuck. I just leaked it. Fuck. New secret. Oh, man. Fuck. It's so hard. You know what? Fuck it. We just leak it. I don't see any reason why this is gonna be a problem. And you know what? We'll just run it. We'll run it. This is too hard. And I think that we're so lost that it doesn't fucking matter anyways. All right? Just don't do anything evil. But I don't think you can, so it's fine. Okay. So let's start again with running this command, because if we generated a new secret, maybe it's going to expect something new. So we'll run this. Curl. What the fuck? What is happening? Oh, do I need to like ampersand or quotes around this thing? Oh no, we did this over here. I don't think you can. Famous last words. Yeah, true. Why can't I connect at all? Why is this going to localhost? Oh, because I've authenticated. I see. So this is the response. Got it. Got it. And then we should be able to go back and do that second command. The second command, which is get us the auth token. Which, oh, this is implicit grant flow? How did we end up here? I think I have this page open like 4 times. Okay. Authorization code flow. We ran this response type code, client ID, redirect URI, chilling, OpenID. Oh, why does it just say and OpenID? This should say scope is equal to OpenID. State nonce. Okay. There we go. So now it's asking me about OpenID. We're chilling. We copy paste this. This goes here. This is our response. We have a code now, and we should just be able to curl with this post token to this website, this thing / token. We run post with URL encoded things, client ID, client secret, client secret. Code is now this code because we got a new one. Grant type authorization code is what they said. How the fuck does it keep authorization code, and redirect URI is our redirect URI. Yeah, we run this. Invalid client. What the fuck does that mean? Invalid client. Like, am I high? Echo client ID. This seems like fucking what we had in our developer console. Do you have a reason not to use the implicit grant flow? I'm pretty sure that the way that this is set up is that, like, I'm supposed to, on my side, validate, like, if everything's usually need to whitelist redirect URI in the console. Not sure I understand. So I think that the implicit flow is because everything is client side, and so if I don't trust you guys because I am behaving, like, doing things for myself on my server, then I can't use that flow. I think that's my understanding. I'm pretty lost, to be honest. Invalid client seems like Twitch. Invalid client. What is this complaining about? I'm assuming that it's complaining that my client ID is shit, but what am I doing wrong? So they are saying, here's my client ID, here's my client ID. Means that the client ID is not valid. You may have copy and pasted it wrong. I mean, I'm pretty fucking sure I didn't. Like, is this app? Ball machine? Manage? Client ID. Am I fucking high? Do you need to pass the content type header as form URL encoded? I'm pretty sure it was. Right? If I type -v here, I see XWW form URL encoded. Do it without URL encode. So you just write --data like this. What the fuck? Why is that different? Oh, data URL encode is probably fucking I see. Okay. So we got something back. This gives me an ID token, which is a fucking long ass string. He gives me my nonce back, which is good. So it looks like Twitch. So I gave my user this nonce. the user sent that to Twitch, and then Twitch sent it back to me. So there's probably something there. I have refresh token, access token. Okay, but this access token is probably the interesting thing. Probably. And you guys can't do anything fucked with that because all it has access to is like listing my IDs and stuff, which is public information. So it's fine. Probably. Probably. I lost the flow. Twitch, ODIC flow. Oops, we are on this code flow, and we've got through step 2 now. It returns access token, blah, 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 ID token. Doing auth dev work live seems fun. Yeah, I mean, there's nothing that could go wrong. Nothing that could go wrong. When the access token expires, use the refresh token to get a new access token. Okay, sure. We don't care about that right now. Requesting claims. And for more information about validating the ID token, see validating an ID token. Okay. So claims identify information about the user that authorized your app. The following list includes the claims that your access token and ID token include by default. Okay. To include non-default claims, blah, blah, blah. Okay, I don't really care about that. So I can get user info. What the fuck is, like, do I need this ID token? I'm assuming this ID token is like the important part of this thing, right? You guys are saying that I can like check it out at JWT IO, and I should be able to like slap this shit in there. I see. So this gave me all of this stuff, which is all of this stuff. That makes sense. That makes sense. Right, so this is my name. That's good. And this is, I assume, like where I came from or something. I'm assuming that we have to validate these things in some way. Unix timestamp of when the server issued the token, URI of the issuing authority, Unix timestamp of when it expires, client ID via application. Contains the same value as odd, and this is the client ID. So this should be my client ID, which looks like what we sent. Okay. And then this stuff is like, you know, stuff expires, whatever. URI of the issuing authority. Okay. Okay, so I guess if we were doing this flow in an app, I would now at the very least have my username. Now, let's think about this for a second. If I give to you, an accessor of my website, this first URL, you will know that you can just send some shit to localhost 8000. And you could just try to send something like this and lie, theoretically. I guess this access token has to come from Twitch, though. And so I guess I need to check if I can do something with that access token, and then probably there's some way to validate if this really came from Twitch. I guess I could check who is sending data to me. That's probably useful, and I can say, like, okay, did this response really come from Twitch? And then people are saying that there is a signature field as part of this thing. I see. So they have a RSA SHA-256 of this thing. This key never leaves your browser. Okay. I see. So this, I don't know what this is yet. Payload. I guess we'll see. I guess we will see. But we'll come back to this because we just want to go through the whole flow and make sure that we have like a high level idea before we drill into anything individual. Yeah, they have the section on validating it. Okay. We'll come back to this though because I want to know, maybe that is all we need, to be honest. Just the username? Could be. Yeah, we could ask for other things like user info, picture, ID token, email verified. Sure. We'd be like, hey, what's their email and is it verified? But I don't really care about that right now. The username is probably sufficient. And then to get the claims information from an access token, Send HTTP GET to user info. You may call this endpoint only with an OAuth access token. You may not call it using an ID token. Okay, so I should be able to go here with the authorization token they just sent me. So here I should be able to just, oopsies, swap this guy out with this guy. Nope, because there's no escape here. Okay, and that just gave me the same thing again. Right? This gave me, essentially, when I decoded this ID token, this is like the same shit, just with different timestamps. But it does just have like my username in here. No nonce and stuff. So I guess I don't need to do that, right? It kind of sounds like unless something tells me that for security reasons I have to use this access token to get something, it doesn't fucking matter. Because it's just giving me what I already have. Okay. Validating the ID token is an important security measure to ensure the authenticity of the token and guard against tampering. This makes sense to me. This is like this makes the most sense out of everything I've seen so far, right? Twitch is gonna send me something and I have to go like, did this really fucking come from Twitch? So I need the issuer, the app's client ID, so that's me, the signing algorithm that Twitch uses to create its JSON web key. So I'm assuming the JSON web key, I don't know what that is yet. Was that one of the fields in this structure? Nothing in here looks like, I guess maybe that's what this is. Is this the JSON web key? Okay, what JSON web token? What the fuck is a JSON web token, guys? Compact URL safe means of representing claims to be transferred between two parties. So JWT doesn't say JWK. Let's see if the letters JWK are in here. Jesus fucking Christ, man. What does it mean? Chat GPT. Is JWK and JWT the same thing? No. This is the web key and this is the web token. How are they related? Maybe he'll tell us. It consists of three parts: header, payload, and signature. JWK is a JSON format used to represent cryptographic keys. I see. So the third, oopsies, fuck, I closed the important thing. Is JWT and JWK the same thing? We'll ask the same question, see if it gives us the same response. It's not the same, but it's close enough. So the header, payload, and a signature. Is the signature the JWK? JWK is a JSON object that represents a cryptographic key. So I probably have to get this from somewhere. It probably is the signature is signed with the key or something. I just use 1,000 liters of water. Okay, so I go to this issuer probably. I have my client ID. The signing algorithm, to get this information, call the discovery endpoint. Okay. What the fuck? How come clicking this didn't give me... I see. So I can just go here. And this will tell me... I see. So there's something about he's going to use RS-256. He's going... What's here? Okay. And so then I can ask Twitch for his parameters in some way or something. Is this for other people to log into your website? That's the intent, but there's a good chance that I'm just doing nothing of value because I don't really know. The intent is that I'm hoping that when we get through all this, we will discover that this, in fact, means that I will be able to press a button on my website that does this flow and then tells me that this is user X from Twitch. That's my hope. Okay. So this is the signing algorithm that Twitch uses. For example, RS-256. Sure. Twitch's public JWK. So this is what we just clicked on here. So this is the JSON web key, I guess. So all of this is related to JSON web key. JSON web key. So this is part of an RFC. I see. And what is in this thing? Key. This section provides an example of a JWK. So this looks significantly different than what we saw here. So I guess, presumably there's some sort of like field that is required. None of these things are the same as here. Oh, KTY. Oh, we have KID. KID is here. 1. But the rest of these parameters do not match what we see here. So there's probably like maybe some way to like detect what the format of this thing is. So KTY parameter identifies the cryptographic algorithm. Do we have KTY? RSA. Yep. Check Appendix A. There are more examples there. I'm down to just kind of skip a lot. Like, Appendix A. Example public keys. So this is an elliptic curve. This is RSA. This should be semi-similar to what we have. Algorithm E, KTD, KTY. So KTY says RSA, and the rest of these parameters depend on the key type. I see. So the key type is probably like the required field, and this maps into like an enum or of different possible versions of the keys. And so these are the RSA parameters. So N, E, algorithm. So I guess RS-256 is like a sub-algorithm of RSA in some way. And these are just parameters for it. Okay. Okay. Sure. So we have that thing as that came in. Did that come in with our JSON web token here? Yes, so that we have this stuff here. Okay. And then I don't know what this is, but we'll get there. We will get there. So if we validate the token, we have these things. For more... That's crazy. Okay, so they're like, to verify, you need this info. And then they're like, okay, that's it. we need to know how to do this. So how to validate an OpenID Connect token. Okay. This is like probably like the most important part of everything. You don't need the private key part. That's only used if you want to encode your own JWT using that tool. Okay, perfect. Okay. I don't want to do that. I only want to verify theirs. Okay. Subject, issuer, timestamps, other attributes. Okay, so wait, did we ever figure out? So we use JWT.io to like decode this thing, but we didn't actually figure out how to do that ourselves. I'm assuming that this is like, I can just how do you like base 64 decode Linux? I'm assuming that this is just a base 64 encoded string. Is it just the base 64 tool? I can't remember. Base 64, yeah. This. Nope. How do I say that I want like this thing as a file like this? No. Decoding strings. Base 64 decode. And then let's try doing what they said is echo this shit and base 64 decode. No, he's saying that's invalid. So I guess it's not just echo -n maybe. No, he's saying that there's invalid shit in there, which it does look like, right? There's like underscores and shit. Which kind of makes me think that this... the dots are separated base 64 encoded strings, but then why is like copy pasting this not good enough? Right? Like echo this, base 64 decode. Like that's not giving me something sane, so I must be missing something. I must be missing something. You need to copy the whole thing? But you're saying that the dots are separated base 64 encoded things. And the sign part, like this is the part I care about right now is the signature, right? If I understand correctly. But maybe I don't. Right, like this whole thing is not something that I can base 64 decode, right? Not the sign part, that's the only non-base 64 part. Fuck! Okay, so if I echo this middle part and do base 64 decode, that's okay, that makes sense. That makes sense. So what is this shit on the right? Does this guy tell us what the format of this thing is? What is the third dot? Therefore, it usually looks like the following: header, payload, signature. So payload is then base64 URL encoded. Okay, signature, you have to take the encoded header, the encoded payload, a secret, and the algorithm specified in the header. Ah, I see. So we take the first two parts, we URL encode them, and then we run a hashing algorithm, probably with the key of the other stuff, and then make sure we get the same answer. I see. So let's double check. So when we read this, that's probably what we're going to end up seeing. Okay, ID token validation. There are basically 3 steps to it. Ensure the ID token JWS algorithm matches the one with which the client has registered with the OpenID provider. So is that the thing that we got from God damn it. There's so much going on. Go back. And then can we copy paste? We got a ID token somewhere. I want to paste that back in there. ID token? Fuck. Where token? It's here. Yeah. So we can copy paste this thing back into here. And this is saying that we have ID token JWS algorithm. Which one's JWS? That doesn't sound familiar yet. We had JSON web token, and then we had JSON web key. What the fuck is JSON web S? What does that mean? Guys, why is there so much context? Am I crazy for being lost? I'm assuming not. I'm assuming that this is just fucking confusing. But this is insane. Okay, I wish, like, the fact that they use just, like, these fucking, like, 3-letter things everywhere, too, is, like, okay, what is JSON web, JWS, JWT, JSON web signature? Okay, that sounds right. JSON web token is widely used, however, Jesus Christ, man. Okay, this is the RFC we want. JSON web signature represents content secured with digital signatures or message authentication codes using JSON-based data structures. Okay, so I'm assuming that this is like the last part of the JSON web token. I'm so okay. JSON web token, it blah blah blah. Claims in a JWT are encoded as a JSON object that is used as the payload of a JSON web signature structure. Okay. Or as plain text of a JSON web encryption structure. Okay. I think that it seems like we're not in the encryption side. We're probably on the signature side, because that's what this is saying. We need to validate the token by looking at the signature. Validate the ID token. The people that dreamt this up are high as fuck. I mean, I'm assuming that there's like probably good reasons, but maybe not. We'll see. Maybe we won't see. We will work through it, and then we will each individually draw our own conclusions because I do not feel qualified to draw any conclusions about this. JWT is the most commonly wrongly implemented tech out there. Uh-oh. I'm definitely going to wrongly implement it then, huh? That's like almost guaranteed. Okay, so we first validate the algorithm matches the one that we found here. Here? Right? So we're saying, hey, when we talk to Twitch, we are expecting an RS-256. And so they're saying that's the first step here. How the fuck do we do that? Validate the ID token against the signature or HMAC. Okay. Validate the ID token claims. So we have an issuer, audience, timestamps, nods. So does this come from the right spot? Is the token intended for the client? But like, why? If we're like, yep, that came from Twitch. What is all this other stuff for? Right? Like, if we trust Twitch, I'm sure that there are reasons for this. I guess like to avoid like replays of somebody else's stuff. So we just have to like once we validate that the signature is right and it's signed correctly by Twitch, then we just want to make sure was this really what we asked for. I guess that's reasonable. That seems kind of reasonable. The complete validation process is defined here. So we are in code flow, I think, or maybe we're in hybrid flow. Looks like code flow. If the ID token is encrypted, decrypt it using the keys. The issuer identifier for the OpenID provider must exactly match the value in ISS claim. The client must validate. Okay, blah blah blah. I'm more interested in verifying the signature right now. That I feel like is the first step. Okay, so this we got. What is the purpose of connecting the ball machine to Twitch? I just want a way to identify who uploaded stuff, right? So we need some login mechanism. We need some account associated with it, right? If somebody wants to like upload a chamber and then delete a chamber or update a chamber, we need some way of identifying people. And identifying them through Twitch seemed like before I started looking any closer, it seemed like a good idea because then you could do some extra stuff like you could like credit the Twitch user, and then when like people see the name in Twitch, they can like tie it back to the chamber that they're seeing on the screen. Right? It seemed like a good idea, but maybe we'll get through all this and be like, this is a mistake. We need the IDP's public JSON web key. Who the fuck is an IDP? Identification provider. That's my guess. So this is Twitch. So this is published as a simple JSON document at a URL. So we have that here. That's this stuff. For ID token secured with an HMAC, we need the client secret to perform the validation. Client secret. Is that us? Our client secret for our app? Maybe. We'll see. So they're using this Java. Oh, God. Can you just tell me what the math is? Like, oh, my God. Okay, fine. It's fine. We'll get through it. So they say, hey, this came from this guy, and we have this client ID, and this was the algorithm they said they're going to use. I don't know what this is for. This seems confusing to me. And then they're just saying, oh my God. Okay, I want to know, like, surely, like, somebody can just, like, this information should be available somewhere of, like, I don't want to know how to use your fucking Java library. I want to know, like, what is the math here? Oh my God. Okay, it's fine. Validate JSON web token. So we have something that's supposed to resemble a RSA SHA-256 of this thing. So what is this? I know what SHA-256 is, but is RSA SHA-256 different? Like what is going on here? What is going on here? I feel like I'm missing some like important context. Compute signature. Okay, this is like some specific library. I just want to know like what the fuck is this thing, man? I guess we'll just have to read the RFC probably for JSON web signature. RSA SHA. Nope, not in here. Oh, okay. So we have this blob. We have a blob. And we know that the algorithm is RS-256. Sorry, not RS-SHA-256. It's RS-256. What the fuck is this? What is it? It was right there, A12, RS-256. I had the numbers wrong in my head and got confused by that. So this is JSON web key. This one is JSON web. Here we go. So A1 You're saying that it was under A1.2, but is this what we are using? I don't think that this is it, right? This is SHA 256, and we have RSA SHA 256. I don't know what the difference is there. I guess we can look, though. We can look again at this and just read through it and see if maybe it'll give us a clue. So I skipped this because I thought that the encoding section here did not match, right? They have algorithm HS256, and we have algorithm RS256. But maybe we can just control F. Here we go. Example JWS using RSA SSA PKS1V15 SHA256. Perfect. I know what the fuck is going on. Algorithm value is different. Second for illustration purposes only. The optional type parameter is not provided. Okay. So the octets representing this header are this thing. Payload. Oh, okay. So yeah. So this is the first thing before the first dot, right? In this shit show, in their example, they're saying we have this thing, we have this thing. Chillin. So this is the thing that they're validating. And they're inputting this shit show into the hashing algorithm. Cool. This example uses an RSA key represented in JSON web key format below. So we have all of this information, which we grabbed from Twitch here. It looks kind of different than this example. EDPQDP. I don't think it has all of those things. But I'm assuming that maybe it depends on something. The RSA private key is then passed to the RSA signing function, which also takes hash type. Okay, so this is very slim. But I assume that we can feed this into some sort of like OpenSSL RSA function somewhere and get what we want. Okay, this is how these guys do it. I'm down to take a look at that. Generate signature. This is the interesting part, probably, right? So they have some cryptography function. They initialize it with the key, and then they just run the shit. I see. So this, we extracted this from somewhere. Expected algo. So this probably comes from wherever, like this comes from something that we parse, I guess, asking, we go to Twitch and say, hey, what are you signing with? And this gets it out of it. Okay. So if I were to try to prove to myself that I understand something, I would want to basically feed these parameters that we got from here into some RSA thing. Like OpenSSL. There must be some OpenSSL command line command that I can use to validate this to make sure that we understand what we're looking at. And so this is saying like we have like this shit. like what is this? OpenSSL. Can we like OpenSSL command line PKCS1? What is like PKCS? Public key cryptography standards. We're getting deep in it. Okay. Okay, let's look at OpenSSL. In the Zig thing, they're using HMAC SH256. Yeah, that makes sense. Okay. Can I like So I want to like verify something with their public key. So I want to like OpenSSL verify signature command line. Right? Surely there are like ways to do this. I can verify stuff with some parameters. Yep. That makes sense. But I need to like parameterize this in some extra way. Fuck, man. So much context. Let's go back. I'm flip-flopping between a lot because I'm just trying to like build a mental picture of this. I wish that this gave me more information. Oh, good link. Verifying this stuff with OpenSSL. This is exactly what I want. Okay. So they extract the public certificate. They like grab it from wherever. Extract the public key with this. I see. So the thing that they got is like more than just the key, probably. So can we pull out fuck. Here? No. Yeah, here. OAuth 2 keys. So is that what they pulled from? I lost it. It was here. So this is the JSON web token. Get Auth0's public certificate. So we need to extract this from somewhere. So Twitch should tell us where their public certificate is. Twitch's discovery endpoint. So they have keys, token, user info. None of these look like... It seems like the keys section must be related, must be equivalent in some way. Probably. Does this tell us how to do anything with this shit? Nope. Of course not. It's the thing you looked at. Okay, cool. Is it the N in the JWK? It's just, I wish I knew. I wish I knew. It seems like it could be. This... Okay, so we could go back to the RFC for JSON web whatever. And we could look for... Oh, this is so useless. This is just like I want them to tell me what it is. RSA's public key is defined by both the N and the exponent. You can obtain that from... Perfect. Thank you, Mackie. So the N modulus parameter is the blah, blah, blah. The E exponent is the exponent parameter. Yep. To create a PEM file that represent this public key information, you basically need to build its equivalent encoded representation, maybe with some preamble. In its original form, it is defined like this. Woof. I see. Wow, what a pain in the ass. Okay. What a pain in the ass, man. There's so much to ramp up on. So they define a key. It has a modulo and an exponent. We need to like convert that into some format that we can use with whatever signature verification mechanism we end up using. Upload JWK inspectors. Parse the JWK to inspect it, validity and status, blah, 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 and then get its keys will be returned in PEM format. Okay, that sounds cool. That does sound a lot like what I want, huh? So we should be able to yoinkies that shit from here. This is our web key. So we should be able to like basically just kind of slurp this shit up. And wherever the fuck that this thing was, this does give us back a public key. So this is super interesting. So we're gonna write this down as maybe somewhere to look at source code for JWK to PIM. But let's just kind of start here. So we have this public key, and then we can go back to this, and we can start running through this shit. So we have Twitch cert PEM is whatever this is. And let's see if we can run this command on Twitch cert PEM and just kind of see if it outputs something. Cannot read certificate. Fuck. Oh, but this is supposed to be the public key anyways. So maybe this is fine. Because this is public certificate, this is public key. Okay. Let's try using this and see what happens. So if we run, this is basically what we're looking for. Right, so we want to digest with whatever our Twitch cert PEM is. We have no signature dat. Where does signature dat come from? This. Decode the signature. Okay, but we should already have this. This signature is just, I believe if I'm reading this correctly, should just be like the shit in our web token. So it should just be, fuck, I lost it. Somewhere we had a JSON web token that we got from Twitch. This one. Where? Oh, fuck. This got fucked up. Oh, everything is so hard. The sign part, but isn't there supposed to be a dot here? Okay, well, we're gonna go back in our history. I think it's borked, yeah. I think so too. Fuck, invalid authorization code. Somewhere we have ID token in this. ID or token. We will find it. We will find it. Here. Okay. Let's maybe copy this and paste it somewhere. This is important. We don't want to lose this. Okay. So we have our JSON web token, and this stuff should be the signature. Fuck. I think from here to here. Yeah. Okay. So this is my signature. And so we should be able to take this thing and go to signature.dat, paste this in, right? And we should be able to run that OpenSSL command, which was from here. And they're running OpenSSL digest. It says SHA-256, and we're verifying that it was signed with our Twitch cert PEM signature, payload. Oh, so we need a payload text, which is the other half. Right? So they gave us this ID token, which has all sorts of shit in it. And we basically just want to yoinkies this shit, put it in our payload, and see if this works. No such file or directory, signature.dat. Do not save it. I probably spelled signature wrong. I did. I said signature, not signature. Verification failure. Okay. I think that shouldn't be the base64 one. Oh yeah, you're right. They did decode it, huh? They did seem to decode it. What is this Perl thing doing? OpenSSL encode base64-D. Decode the signature. Oh, it converts it from base 64. Oh, fuck me. Okay. So this is... Okay, so we have a payload. Dude, bash, man. So this is the base 64 encoded stuff up until the last thing. Then we decode the signature, which is the last portion off it. And so they're just kind of saying, like, take that shit and run this on it. Let's see if that gives me something sane. So this is like echo this, and then fuck. Oh god. Echo. I guess we will go like this. Echo this. Open SSL. Encode base 64 -D. Let's just see what that does. That gives me nothing. Okay, let's maybe run through this guy's script and make sure that we understand what the components of this thing are. So he says, like, JWT is equal to RJWT, which is this. Is it that? No. JWT is equal to this. There we go. So we have this thing, and this is our 3 chunks of shit. Our header, which we believe is a base 64 encoded JSON blob. So if we say echo this part, base 64 decode, okay, that gives us our header. And let's just double check. That guy was using like OpenSSL. I want to see if this OpenSSL command is the same thing. This is OpenSSL encode base 64 -D. Does this give me like the same shit? No. Interesting. What is this? Man, OpenSSL. OpenSSL enc -- help. What does this thing do? Who fucking knows? Maybe it's not happy to write to standard out. Could be. No, it doesn't look like it's just doing the fucking jack shit. So it could be that I just don't understand what this like OpenSSL enc command is doing. Because it really seems to me like he's saying, hey, take some base 64 encoded stuff and shove it out there. But it's clearly not, so. OpenSSL enc base 64. Or help. Base 64 encode or decode. That's what it should do? Okay. So if we say like echo hello world, and then we base 64 encode it, and then you're saying that normally if we did just go back the other way, we get hello world back. And you're saying OpenSSL enc base 64 decode should do the same thing. Oh, it does. Okay. So that at least gets some confusion out of this. So he's basically saying, I've got this like signature and I am doing some transformation to it and then base 64 decoding it to get a signature out. So we're going to go back to this and we think that we take this and we run this now. I don't know why this isn't giving us something, but base 64 -D is. That's what's concerning about it. Maybe this needs like echo -NE. No. Try adding an equals or an equals equals. Oh, because it needs to be like the correct length. That's possible. Oh, he still doesn't like it. It's weird that like when we base 64 decode this thing without OpenSSL, it works fine. If we go back and forth with OpenSSL on one end, it works fine. But then just taking the thing that was like fine. Yeah, I'm missing something. We're missing something. So echo this. What if we do this? All parts in JWK are base 64 URL encoded, so they may not include the padding at the end. I see. So if we take this and then base 64 encode it back, we get the same thing with 2 equals, which I thought we tried here. Right? We did this. Oh, you have to replace some other stuff as well? Ah. Okay, we got there. So this OpenSSL encode base 64-D is expecting a new line thing as well. So I see. So if the normal base 64 command, not the OpenSSL one, does it handle this better? If I say like echo this, oopsies, not this. This is the signature, and I just say base 64-D. He does think it's invalid. So then we can maybe pipe it through this Perl command. Does this kind of give us what we need? There we go. I see. So we need to go, this Perl command is base 64 URL encoded to base 64. It sounds like is what you guys are saying. Transforms between, I see. So how do we know encoding of plus this and this character into special? I see. That's disgusting. Okay, so what do we know? What do we know at this point? Because we've been moving through some stuff. We're still fucking lost, that's for sure. But we have something. So we say we got this. I'm just trying to like recapture the current state so that I don't get like so fucking lost. It was redirect user to authorization URL. Then user clicks authorize. Then Twitch sends our server a code, authorization code. Did it? Maybe it was all together. It might have been all together. I need to look back. They sent us the code. Right, they sent us an authorization code, and then we used the code to get a token. We ask Twitch for token based off code. And then token includes ID token, which is a JSON web token. This thing has a header, which it looked like were like encryption parameters. Yep. Encryption. I guess signing params. Then it included a payload, which is the actual data we're looking for, as well as a signature. Signature with an A. All of these things are base 64 URL encoded. All of these are base 64 URL encoded, which is not base 64. Perfect. Okay. Then after all of this, we are supposed to check. We're supposed to like ask Twitch for its sign-in key at whatever the fucking fuck, I just closed a tab that I didn't want to close. It was something about like well known somewhere? Discovery endpoint. Yeah, so we went to this. Right? This gave us where we went? Yeah. We went from ask for its signing key at here to keys JWK KS URL here. Yeah. Yeah. Okay. So then we have the key, and we are now trying to decode that key in some way. So I guess we should kind of take this shit and maybe like slap it here. Whatever. We'll come back. We'll fix it later. Okay. Okay. And this website here. No. One of these Stack Overflow posts was helping us understand how the fuck to verify this thing. This guy. This is helpful. To verify SIG, look here. Okay. Now we should be a little less lost, but still very lost. So we turned this thing into a signature. So this is all signature dot whatever the fuck he wanted. He wrote it as .dat. Base64 invalid input. Didn't this work like a second ago? Yeah. Oh, he's actually claiming invalid input still. Fuck! Why is it invalid? What did we miss? Oh, is it echo-n maybe? Then base64 decode. Now there's no invalid input. Perfect. And we can put this in signature dat. Okay, and then theoretically we have all the pieces we need here. Right, it was this thing, but we had Twitch cert pem, signature payload. Verification failure. Fuck! What's in our payload text? It's possible that our payload has an extra new line at the end that it's not supposed to have. Nope, maybe it is supposed to have the new line. No. I wish that we could get like a... I also don't really want it to like verify. I want to like see what we would get if we were to shove 256 this thing. But I guess we need their certificate in some way. Okay, it seems like that Twitch certificate must be valid. Oh, we also should write down where we got that from. Somebody linked us some website that converted the JSON web key, convert JWK to PEM at this. Okay. You can do this OpenSSL command. Could not read certificate from twitchcert.pem. But I think it's because it's a key, not a certificate, was kind of my thought up until this point. Okay, let's maybe... The signature of a JWT is base64 URL encoded, needs to be decoded first. The suggested duplicate only deals with base64 encoded signature, and OpenSSL seems to not be working with base64 URL encoding. If you're a Windows system, you can decode the signature file cert util, which we don't have. We're not on a Windows system. Oi. All right. Let's try closing some... There's too much going on here. Let's try to reset our state a little bit. Okay, let's look up JWT verification OpenSSL command line. This is different. Wait, this is... Oh, this is not exactly the same. This is close. So this is not the right algorithm, right? So we don't want this. We want to look up specifically one with the one we got from Twitch, which was at that URL. So we have that logged here. RS256. So we just want to throw that in here. Okay. So, oh, this is generating though. We want to verify, which I guess is the same thing here. So OpenSSL digest SHA-256. Instead of sign, we are verifying a signature. He echoed into this thing. What does this dash binary flag do? Why not just do it in Zig directly? I want to like understand the pieces before jumping into like Zig code, right? That's why like I feel like starting with command line and like piecing the pieces together will help with understanding the pieces of the puzzle. You know what I mean? You know? Uh verify. And maybe we punch in Google here. It does seem like this is what we want. I was just looking for like another resource. Because this one isn't doing what I want. It's not working. And so I just need to I'm trying to figure out where have we gone wrong? Where have we gone wrong? Because it feels to me like okay, let's look at like if each of these components is looking okay, then why is like it not working together as a whole, you know? You know? Okay, let's like remove signature.dat just to make sure that I didn't like fuck that up. Let's remove twitch cert.pem and like regenerate it. So twitch cert.pem came from some website. This. So we took this key in its raw format and we pasted it into this website. Yeah, I think somebody else already linked the Zig JWT thing. I was just hoping to like start somewhere else. I was hoping that I could start here on the command line and then move into Zigland later. Because I feel like I don't like there's so much I don't understand that I was hoping that I thought this would be simpler, you know? Signature det. Signature with an A. Signature det. And let's paste this key in here. And is there a way for us to verify? Can we like open SSL parse pem? Like, is that something that we can do? I just want to see like, I want to see if like this is a valid. This is a public key. Good point. OpenSSL. Like, I guess like printing. If this is just a public key, then it's just a public key. And like, what are we gonna do with that? Okay. So we have key. We have signature. OpenSSL digest 250 SHA 256. Verify with our. We need to. Oopsies. This is supposed to be Twitch key pem. Oops. Our signature is supposed to be something else. What is our signature supposed to be? It is supposed to be what we extract from our JSON web token. Do we have like base 64 URL decode? Base 64 URL. Ah, fuck it. We will use this pro command again then. So this, we take in our. Oh, fuck. Oh, fuck. I want only this part. Copy, paste. We want to echo our thing, then take this out. So we were in login text. This is our signature. I guess we should just we should re-extract it from this guy, just to be sure. Okay, so we have this thing. And then we should be able to base 64-D. That is something valid, except we want to make sure that we don't have new lines in our thing. He doesn't error out in any way. And then we just say that this is our signature. Oh, let's try the OpenSSL enc base 64-D, was it? Maybe it's going to give us something slightly different. But if we can get to give us anything at all, maybe we have gone onto the right track somewhere. If you have core utils, you can use base enc. Ah, yeah, so this has base 64 URL. I see. So if I echo in this shit show of thing into base 64, no, it was a base enc -d with base 64 URL. It does give me invalid input. Because I didn't copy the whole thing, I think. Okay. Ends in a G, ends in a G. I think we're chilling. Okay, he likes that. I like this command better because it feels like I'm not like stitching together a bunch of stuff. Okay. So this we can go into signature det. Now let's also double check our payload. Our payload should just be the other two components of this thing. So this was up until the first dot and the second dot. Which it feels like we got pretty good there. That feels right. First dot ends in a 9. This ends in a 9 here. Y is J9, Y is J9. Now, do they expect their payload? No new line. No new line. And their input is this shit. So let's see what happens actually if we print this. So I think that we had our thing exported as the JWT variable, I think. Yep, and this is the same shit where it takes the first two components up to the line, so that's what we're expecting. What's with the raycast loop? It's kind of hypnotizing. That's the point. It is hypnotizing. And it's because coding is boring, and when I'm lost, it's even more boring. And so, this is why it is there, so that there's something to look at. Cannot open file URI loading public key from twitch cert.pem. I call it twitch key.pem here. Wait, let's go! Let's go, baby! Okay, so we just made a lot of mistakes all over the place. But I think that now we have at least some understanding of what this thing is. I don't think I really understand what this like digest SHA-256 verify is doing. Right? So like I understand that OpenSSL digest is saying, hey, this thing is like we've done some form of SHA-256 on something, and then we signed it with some key, and we got this output, right? And so I wonder if we can prove to ourselves that we understand this by going the other way, right? So my assumption here is that they used some private key to transform the input data, and then they took the output of that thing and turned it like they ran SHA-256 over the output. Maybe can I look for? Okay, maybe this is one of those cases where maybe ChatGPT will put me on the right path. Could you explain what this does? We'll start here. Fuck. Shut the fuck up, shut the fuck up, shut the fuck up. I hate you, ChatGPT. Stop being so nice to me. Make me feel bad for not pasting. Okay. Can you explain what this does? Digital signature. Okay. OpenSSL digest. This is the command with OpenSSL. Yep. Specifies the hash function to use. Blah, blah, blah. Verify. Yep. Oh, here we go. Process explanation. OpenSSL calculates the SHA-256 hash of the contents of payload text. Then they use the public key stored in here. I see. So it's the other way around. Is we take some data, we SHA-256 hash it, then we encrypt it with our private key, and that should give us what is in signature.dat. So if we were to generate a key pair, we should be able to generate a JSON web token that kind of matches what we expect. Could I ask what computer program you're using? First time chatter here. I don't even know. We're kind of like stitching together a bunch of shit. I don't really know exactly what you're asking. We're using, this is Firefox. This is on a website, ChatGPT. This is a terminal emulator. We're using OpenSSL to try to stitch together some things that we've been clicking around on. We're not really doing much like coding right now. It's more like info gathering, understanding. Okay, it would be nice. This is actually good job, ChatGPT, by the way. This is probably like the best way that I could have got this information. But, you know, he could have been wrong. But God, like decoding stuff like this is so nice. Like this is often, very, very, very often, I talk to this guy and he's just the fucking dumbest piece of shit that I could ever deal with, right? He's just wrong. He's like, I'm like, could you explain this? And he just says something else. But sometimes he hits. Okay, say I wanted to generate a signature for that payload. How would I generate a public-private key pair, and what OpenSSL command would I use to encrypt to sign the data? Okay, so I can generate some sort of key pair, sure. Sign the data. So I don't want to do this. I want to go more manual than this part, I think. I want to see if we can SHA-256 the stuff ourselves, then do the signing after. That's kind of what I want. So what if I don't want OpenSSL to do the SHA-256 and I want to do it externally? I'm assuming that there's like an OpenSSL enc command that it'll run. Like this still doesn't feel right to me. I think this is wrong, by the way. This just like, here he like calculated the SHA-256 and he just did it again. What are like my OpenSSL subcommands? Is there like a sign? Okay. Let's ignore the SHA-256 stuff. Say I have a message and I want to sign it with RSA. Is there an OpenSSL command for that? Oh my god, dude, his fucking tone, this bitch, he's always so mad. Or like, he makes me so mad by being so chipper. This is probably what I was looking for. Okay. This seems like that might be reasonable. So let's see what happens if I were to create a private key. Error writing key. Do I need to give it a passphrase? No pass. Nope. 1, 2, 3, 4. 1, 2, 3, 4. Fine. We'll give it a passphrase. Remove the AS256 part. Ah, okay. And now I have private key PEM. Okay. Now I want to get the public key from it. So I take the private key and I create a public key. Cool. Now I want to SHA-256 sign some data. So maybe we'll take the payload and what is in this payload? This is the JSON web token shit. Okay, so we can try signing this thing. So this is OpenSSL RSA-util in key. So we take the SHA-256 sum of payload text, and we want like, that's fine. We'll just copy this. Sig.text, we'll call it. I'm not sure if saving in Vim does the same thing as doing this, so we'll just do that. Oh, fuck. Oh my god. Okay, sig.text. Okay. So we want to sign with this thing. In is sig.text. Out is my signed dat. Okay, sure. So now we should have something that we signed with our thing, and we should be able to run basically that same command that we ran before to verify. And if we understand everything correctly, we can just swap out the Twitch key for our thing. Fuck. The Twitch key for private key pem signature was sig text. Could not read public key. Oh, it was supposed to be public key. My bad. Check the output of the sign command. It failed. Oh, did it? I thought it just said that it was deprecated. Yeah, I think it's fine. I think it's fine. Wait, did I dash out? Yes, yeah, my sign.dat. So this is supposed to be my sign.dat. Still no good though. Bad signature. So I'm not really sure that I did all those steps correctly. So we have a private key and a public key, and we just want to sign something that we SHA-256 do ourselves. So we did SHA-256 sum payload text, and we copied this, and we said echo no new line this thing into SHA sig.text, I think is what we called it. That makes sense. Then the thought was, if we understand everything correctly, we should just be able to sign that thing. Oh, I think you want the SHA-256 as binary data, not hexacoded? That makes a lot of sense. That makes a lot of sense. Yeah, I think that would do it. Can we SHA-256 some binary? Can we like make it do that? We can. Payload text. Fuck. Read in binary mode. No, I want to output binary mode. No, I guess we can't. But we can easily convert this thing, I guess. If that is, in fact, the problem. If that is, in fact, the problem, we could do this. Oopsies, Python 3. SHA is equal to this. Oops, like this. And then can we like Python 3 hex 2 bin? Oh, this is this what I want? This gives me an integer, but I want like each component. Pwn utils is perfect for stuff like this. It feels like this should just be like straightforward. Bin ASCII. This looks like what I want. So I take this and I take this, and this gives me a bunch of bytes, which is right? If I look at the like length of this thing, it should be half the length of this thing. Yeah, okay, yeah, that looks like what I want. So I can take this thing and I say SHA bin, binary version of this SHA. If I open some file, which is sig.bin in write binary as f, we can just do f.write SHA bin. And if we then look here, we should see that du binary SHA bin should be 32. No, sig bin, sorry. There we go. So we have a 32 byte file, and then we had our RSA util thing, and then just instead of doing sig.text, we want to look at sig bin. And then we want to verify my signed dat. Still no good. So there's lots of ways that we could be making mistakes here, right? It's either we don't understand the signing process, or we've just fucked up some Unix utility. And like the Unix utility stuff seems more likely to me at this point. Sucks because I really wish that like I want to be able to like prove to myself. I want to be able to prove to myself that I understand the components, because I think that like I just think it's like really, really important when you're working with any data to like really get the data. You know? Sig.bin on the verify. I think sig.bin. Yeah, that actually could be it. No, because we took this. I think the flow was we went from payload dot text to through an SHA-256 to sig.text. This is a hex string representing the SHA-256. Then we like binary encoded into sig.bin, which is a 256 SHA-256 signature of the payload. And then we went from here into my sign.dat by signing the signature. That was this stuff here. Sign, in key, private key. Just dump the file as binary into the shell first to test. We could do hex dump sig bin. So this should match the same as oopsies, hex dump -c. This should be the same as cat sig text, right? So this is in fact the same. This is the signature of payload.text. Payload.text has no new line. Let's go back to trying to verify with Twitch's key. So that's okay. So we know that the payload is reasonable. Can we do like OpenSSL digest SHA-256 payload text? What does that do? Interesting. So that's like the same string at least. The SHA is the same. Verify my private key.pem signature was, we just went through that whole thing. My signed dat. Oopsies. And then oopsies. this payload.text had to go at the end. Could not read from private key. Oh, this is a public key. Oops. Okay, what if, okay, so now how else can we break down this problem, right? We could maybe look at the, try making sure that we can just encrypt and decrypt something with the public and private key. So can we just say, like, echo something, cat hex dump dash c my sign dat. So that is something for sure. rm my sign dot dat. Let's make sure that did what we want. Okay, and so theoretically, if I want to verify, is that a thing that we can do here? With public key pem in dash OpenSSL RSA util help. RSA util help. I know he's saying to do something else, but we've already walked down this path. So verify with a public key, and then we have a pub in. And we need to verify something. RSA util verify signed data. Right, I just want to see if like we understand how to use our data at all. Oh, so we dash in is this dash pub in. So we verify with our input key is my public was public key pem. Our input is from oh, I see. So they create some sort of output. Oh, okay, I just don't understand. I just don't understand. There's too much new stuff. OpenSSL does this in two ways. But in my case, it says blah, blah, blah. So create a digest assigned, sign digest with private key, create digest, verify. Okay, maybe we just accept this. We can just accept this. I'm okay with that for now. I think that I'm pretty sure that I understand it, and we're just like fucking up some sort of like minute detail. But I'm pretty goddamn sure that this is like create digest, sign digest, where the digest is SHE256, and then they verify. Yeah, I think that we understand it. I think it would be nice if we could generate our own web token by hand. But I'm getting lost. I'm getting lost in the details. So, how far do we get? Also, am I fucking crazy that like, is this supposed to be this hard? Am I like making my life harder for myself? Because it seems like I don't understand how you could possibly use this thing without going through this process. Right? Am I nuts for thinking that? Like the idea that like we need to understand the data and how to create it and how to decode it, it just seems like very important. I think nobody validates signatures. You have to though, or else like there's no point, right? People just use the library and call it a day. Oh, that's not. We're not doing that around here. Okay. Okay. I think my head hurts. I think we're gonna take a break. I think that we have like a pretty good summary of what we did today though. Right, we have, what have we done? We've like asked a user, us, we've like, well, asked user. We generated a URL, we went to that URL, we authorized Twitch with our application. We authenticated, We said, hey, Twitch, this application is allowed to get my ID. He sent us a code. We got a JSON web token that we tried to verify, and we spent a lot of time kind of like tracing down how to verify this. We did successfully verify one of these on the command line, but we were not successful in generating one for ourselves that we could verify. Please refer to my previous comment. JWT is one of the most commonly wrongly implemented tech out there. That seems possible now that we're going through it. Someone else is saying, can't you just use the Twitch key without OIDC? So I think that like when I was looking through this before, when I was looking at like Wikipedia OAuth, just like this kind of scared me off, where they're saying like using OAuth directly as a way of authenticating your user isn't really right, because technically you might just be getting an answer that this person is allowed to act on that user's behalf, which isn't necessarily the same thing. I feel like it would be, I find it frustrating that vendors use these OpenID flows even though there's no third-party identity provider. I don't understand how it became the go-to solution for everything. The normal auth flow seems a lot easier. Yeah, I think that like just getting OAuth, I felt like I wasn't so lost in. That felt okay. It's just like the claim here is that OpenID is providing something extra. And then I was also hoping that we would get through this stuff, and once we made it all the way through, we would be able to at least like poke some form of holes in it, right? Like, oh, this is why they do this. This is why we have to do it that way. But I'm just like more confused after all of this. I think people saying that you don't verify the token, I feel like there's like a potential okay behavior there, right? Because we can get the same user ID through what was that, like user info URL? This, right? And we can like the user is not correct. Like this authentication token that we got has to be for that user. So maybe there's something there where you could skip the JSON web token stuff and just use this directly, but it doesn't feel right to me. It doesn't feel right to me. It feels like we should, like, the whole point is that they're giving me this JSON web token. It feels like it has to be done. Yeah. Okay. Okay. Well, I'm gonna like probably look at this off stream a little bit. It would be nice. I want to be able to like understand. I do want to get through this and at least understand how this flow works. I think that we've got like the pieces of it, right? It's that they give us like a key and a payload, right? It's at a high level, it's simple, right? They give us a key and a payload, and then they sign the header and the payload together by doing an SSH 256. They like pipe it through SSH 256, which gives you like some bucket of bytes, and then they sign that bucket of bytes with their key. And all we are supposed to have to do is look at that bucket of bytes and their public key and go the other way. And it's just that we're kind of getting stuck in the details. So I think I'm gonna call it there. I'll probably try to get some more off stream. It would be nice if we could. Maybe I'll try to get to the point where in some code I have like, I just want to make sure that like I get I want to be able to go through the process back and forth, and I think that I'll probably have to do that off stream a little bit because it's taking too long. And then hopefully I'll get through that and we can come back tomorrow or maybe Friday and actually do the implementation because Jesus Christ, man. Jesus Christ. So check out the PQ util versus RZ util difference also. It should help clarify the difference. Yeah, you're right. That should help clarify. I agree. So thanks for watching, guys. I apologize. This wasn't really much of a coding stream. It was much more of a I'm fucking lost stream, but hopefully it was still fun. If you like what you saw, we stream most days at around 2 o'clock Pacific time for around 2 hours, so we're hitting the 2-hour mark now. If you're new here, there's a YouTube link in the Twitch description where you can check out all of our previous projects. Right now, we're working on this Rube Goldberg machine, but there's other stuff in here too. You know, you might want to go check out operating system, QR code decoder, like terminal emulator. Like there's like some fun stuff in there if you want to go check it out. If you're watching on YouTube, there should be a Twitch link in the YouTube description where you can swing by and say hi. I think that that's all we have to plug, and I think that we can say goodbye to YouTube, and Twitch, let's figure out who to raid.